Uh,
Already joined in for I haven't joined in. Hi. Hi there.
why are you streaming at 3 a.m. of all times?
Because it's 3rd of January, isn't it? That means 1, 2. Hold on. That means 1, 2, 3, 4, 5, 6, 7. We have 7 days to get to stream 1050.
Oh yeah, we actually need the number to get there as well. I completely.
Yeah! I know! I know we do. That's why I've been streaming so goddamn much recently.
Yeah, I completely forgot that was a thing.
There are a lot of things that still need to get done. Hi there, Rosarima. Hi there.
Gang is 3 a.m. for you, it's 3 a.m. for us as well.
You're also working on math. Well, so are we.
So are we. Oh my god, us.
And speaking of maths, I don't know what to
Oh
say.
yeah, speaking of maths, you've looked at the revision notes, right?
Which ones? Hold on.
The ones that Remco shared.
Today, you mean?
Yeah, I actually don't look at it yet. Let me finish up my
Because I thought
section.
they were the same ones. They're
Yeah,
just
they
yeah.
are the same ones.
Okay.
Yeah.
In that case, I'll be honest. I haven't really looked at it in depth because I just assumed they were the same ones, and I have looked
I
at the
mean,
last one.
there are some interesting things about linear maps and stuff. Are you going to sleep, traitor? Anyways, there are some interesting things about linear maps that you can see there. Okay, bye, Rez.
See ya. See ya, Rest. Have a good one.
Wait, didn't we have a rule in Discord to not sleep or something?
I think was a. Yeah, I mean that is true.
Ban Rez.
There is a sleep that there's a rule that sleep is forbidden.
Yeah, ban Rez, bro.
Yeah. Also, if you die on the server, you die in real life. So
Ah, brilliant. Busy day tomorrow. My guy, it's a weekend tomorrow.
is it? Is it the weekend today?
Oh shit, it's today, fuck. It's also tomorrow, so point still stands, but. Also, he said tomorrow, and tomorrow's the weekend. There is no logical flaw in my argument.
I wasn't disagreeing. I just said it's also today.
Yeah. Uh,
Can think of covectors or bases or bras as actions. These images. I realized that there. Yeah, I don't know why, but the word covector feels off. It feels.
correct.
Yeah, because like it may be just me, but it doesn't like the fact that it's a linear map doesn't feel very vectory to me. I get the idea, which is you need basically the same kind of feel, the same amount, to describe it perfectly, but I just it's yucky.
I mean,
Operators.
yeah, I mean, I understand what you're coming from. I mean, where you're coming from, what you're coming from, genius. But the thing is, like, a vector isn't really a vector either. Like, okay, maybe it is. But a vector is just as abstract of a thing. The only reason why it's easy to think about is because you fix a basis and then you think of a vector as being expressed in that basis. If you just take the basis away, then a vector is just as abstract as a map.
It's not about it being abstract; just feels like very different. So it feels like a difference between a function or just an element of a field.
I mean, yeah, I suppose. I mean, naming conventions are bad in like a lot of areas.
Oh, I'm gonna do a cliffhanger, and I'm gonna leave it for the next video because the time evolution. I should really rewrite the entire time evolution operator video because it sucks. Videos get progressively shorter. The derivatives one was 13 pages. The brackets is gonna be 6 or 7, and the time evolution operator is 3. There we go. And in that case, what does it mean? Well, it would mean would. Hi, the ninja. How you doing? The image particle applying a filter that only filters information about energy. Honestly, bad crusher. You did deserve that one. So that's why this equation is the equation for the expected energy of a particle. Page for the time evolution operator. As I'm not, no. The point is I'm gonna be working hard, not hardly working. And this should take less time, hopefully, fingers crossed. 6, not bad. It isn't bad. The problem is that I really wanted to make 4 videos, didn't I? That's because the Schrödinger's one. But the Schrödinger's one, I am hesitant. 4 videos, didn't I? Oh, jeez, that's me. Hi there, Holy Thinkable. Hi, how you doing? How's the day going? All night? All day. I don't discriminate.
I don't discriminate. Ah.
Gets expected energy given a specific basis. Is a bit more complicated, but in order to study that, I have to go over operators some more in depth. So, and then dot dot dot, that's gonna continue the next video, and then let's rewrite the entirety of the time evolution operator. Slick! I do have my... I am so glad I took my notebook with me. Because now I can just open it up and I feel like a wizard whenever I need to just... Okay. So.
A whiteboard.
Yes, so and such. In this case, in this video, the time evolution operator video, there will be all the context about derivatives required. Theoretically not about partial derivatives, because I ran out of time, but how important are partial derivatives? I'm certain they're not important. And also the states, because the Browns cats would be hopefully perfectly explained. Which means we can start with... Oh, no space involved, there we go. We can start with this, so a state. Is there any space here that I can, well, I suppose I can move these big green numbers. I don't know what they're here for. There we go. That's fixed. That should be enough. So, first things first. Alpha So as a state, second thing second, we introduce the time dependence. So all of a sudden, the state actually changes on its own through time. Then, then the next thing is going to be alpha t naught t1, which would represent the state at t1. So, why is actually the notation? Do you know why the notation is alpha t naught and then the t? Like, is the t naught here meant to represent when the state started?
No, I think T represents when the state started, and then T naught is the small nudge in time you give it, if I'm not mistaken.
But hold on. So then when I have a state like this, right, and I give me a second, let me check this. No, not this, not this, not this.
I
Wait,
think it
what?
was written something like
Oh, but it
this.
is.
T and semicolon T naught. I think it was like this, if I'm not misremembering it.
Like this, you say. Then I do have it noted down incorrectly, because
Just check Remco's notes. Wait, hold on.
Oh,
The ones he
that's
sent,
actually reasonable.
plotting and scheming. Time evolution, this one. Never mind, it is T not T. You are correct. I am wrong.
I am always correct.
Indeed. Yeah, so one of them tells you when it started, the other one tells you how small you're giving it, essentially.
Okay. Meet festive. Right, so T naught is started and then T is the nudge from the starting position. So this will be the 3. Then after that, I'm gonna introduce as a 3.5 more like. It's gonna be the time evolution T naught. And the whole point there will be that it's that's how the time evolution, that's how the cookie crumbles, that's how the time evolves. Absolutely bloody terrible. T naught, there we go. Then the fourth point will be different properties of the time evolution operator. So it will be T naught, T naught. It will be T naught, T1, T, and that is it. Then certain function is in the works. I'm working on this last chapter, which hopefully gives a good idea what kind of person my character is. That's it, I promise. Good for you, Ninja. Good for you. I'm also doing a little bit of fun fiction, except it's not really fiction. I'm not really a fan. I'm just doing videos. When it comes to Taylor expanding the time evolution operator,
Okay.
I'm thinking, hold on, I'm
Yes.
thinking how to go about this. Because once again, I really like the way that Remco did it with the omega term of, 1 minus I omega
Yeah, that.
dt, and then these two need the same dimension. But I just don't know how, if it's not unmathematical, if you will. I am the pioneer of make it fan fiction. No, don't take that away from me. If I had a nickel for every single time someone promised me fan fiction of myself, only to not deliver, I would only have one
I think
nickel.
you'd have 3 nickels.
3? Really? Jeez, I lost track.
Which is a lot of nickels.
That is, I've lost track. Also, I think, actually, the way I'm gonna do it is, we might do 3 videos, because I don't know if the 4th one is necessary.
Sure. I mean, you're the boss. To quote Bennett.
The tone of voice you used made me hate myself so much. It was like such
Look,
a employee who clearly doesn't want to be here and couldn't give less shits. Like, fine,
no, no,
let's
no.
do.
Not that is just that is like it is super late and my, let's
I
say,
know, but
tonal range is very limited
I
at the
know, but it
moment.
was genuinely hilarious. Like, oh, that fine, you're the boss. Let's do it. It was really funny.
Uh,
Because of fact. I'm looking at the notes right now because they're all gonna be in the video, and I think backtracking is a waste of time. So I don't want to cover anything that. So I don't want to cover anything in the videos that will be on the stream, because they will all be on the stream. And then after the stream, we
yes.
can make another video, and that video would be the post-stream video that would just contain everything that happened on the live stream.
Mm-hmm.
I'm looking through the notes. I don't want to spoil the notes on stream, so I'm just gonna this definitions. Yup. Matrices. Yes. It goes straight from matrices to quantum mechanics.
Yeah. Because there's still a tiny bit more stuff to be done in the linear algebra section, but no, I think it's gonna be pretty abrupt because we're just gonna go over properties of matrices like, transpose, unitary, inverse,
Yeah,
and whatnot. And after that, the linear algebra section is pretty much done, at least for the purposes of this live stream.
makes sense. Does make sense.
Yes.
Okay, in that case. In that case. Also, another thing.
Yes.
I just remembered that it's actually going on YouTube, so I actually need to make the videos appealable. Because I genuinely shit you not, with this one I was gonna call it something like time evolution operator, but I probably shouldn't. How does one title a video about a time evolution operator?
Evolving state vectors through time. I mean,
I think we might break YouTube's algorithm. I'm afraid that might be too successful.
oh, you
We
mean algorithm wise? Holy shit!
we
Okay,
are
that's
so good
amazing.
at this, Ash. So far, I'm noting them down. I'm noting them. Hold on. So far, the first one is time evolution operator, and the second is evolving vector states through time. We're rolling. A/B tests can have 3 different ones, so we have room for one more because I don't think we can perfect these 2 more. I think they have reached the limit of how good they are.
Peak peak titles.
I do something with trains and satisfactory. Oh, that old chestnut. I've been there. Hold on, let me get my strong coffee. But last title and thumbnail are not important. I just remembered right now that I don't have a single pick. Right now, the more important thing is the contents. That is the important thing, I would even say. That's because after this, what do I actually want to reach? ... What is the last point I want to reach in this video? Well, that last point would be, I imagine, the Schrodinger's, actually, or solving the time evolution operator. I think solving would be better, would be more interesting. In which case, time evolution operator of t from t naught is the exponential of An integral and then Hamiltonian of t? What? There's no way I got that right. Exponential of minus I h bar. This feels somewhat relevant. Then integral t naught to t of dt of the Hamiltonian. Is that the Hamiltonian? That is not.
H is the Hamiltonian, yes.
What is the Hamiltonian in this case? Oh, don't tell me it's abuse of notation. Something is fishy here. Is this an implied Hamiltonian operator applied on the time of... No, it can't be.
No, this is the Hamiltonian operator, but it's time dependent.
Exclusively time dependent.
Explicitly, yes, explicitly time dependent. What do you mean explicitly or implicitly?
Because
Either
I
a
am used to...
Hamiltonian.
Well, I'm used to, you know, Hamiltonians being dependent on position, momentum, and, like, optionally time. That's what I'm used to.
Optionally time. Okay.
And
Oh,
the-
you mean in that sense?
And the pickle
Yes.
here being that, you know, the position and momentum are missing. And I don't know how you would determine the Hamiltonian without the position or momentum. Unless they're
Honestly,
implied.
fair question, but I don't know how a Hamiltonian depends on position or momentum, so I'm not qualified to answer, unfortunately. But in this case, you have explicit dependence on time. I mean, one way you can think of it is that you're just keeping your position and momentum fixed and you're only varying it through time. That's one way to think of it.
There we go. But then, why would this be equal to the time evolution operator then? If you're only going through time, I feel like the time evolution of a state would also change the... No, wait. I don't know.
I mean,
this is awful.
the Hamiltonian H, it's called the generator of the time evolution operator, and the idea is like the Hamiltonian, if I'm not mistaken, I might have to double check this, but if I'm not mistaken, the Hamiltonian is only good for tracking infinitesimal changes through time, sort of like a derivative is.
Yeah, but the pickle is that right here we're like, I think we're trying to arrive at the fact that it's a generator, right? So, you know, we're starting with the time evolution operator, and then
Yes.
we're getting to the Hamiltonian by asking, okay, what is our time evolution operator actually? And then that's the big reveal as a generator. So
Yes.
I'm trying to figure out how, why. Actually, hold on. So are you holding on?
Yeah, I am holding on.
Okay, well then, hold on, because... Hold on. Are you still holding on? Taylor expansion! Okay, got it. So, we start with time evolution operator, t plus dt, t naught, state alpha. Then we blow it up into two separate time evolution operators, t and dt, t and t plus dt, obviously. Then we take the u of t plus dt and t, this one, the infinitesimal one. So we have the non-infinitesimal one and the infinitesimal one, and we use the infinitesimal one to Taylor expand it. And we take only, term-wise, we take only 1 minus I omega dt. All the other terms are nothing. Close enough.
Yeah.
Basically nothing. Infinitesimal is basically zero anyway.
Dear God.
I think you're gonna like my derivatives. You know what? I'm actually gonna export my derivatives video in the background. and send over just because I think you're gonna enjoy it.
I don't think you and I have the same notion of enjoyment.
My favorite part is when I do the 0 times 0 divided by 0. That's my favorite bit.
You okay. Okay, I see how it is.
Okay, but however, and such, Taylor expanded right here. I'm not gonna cover how Taylor expanded because Taylor expansions required their own video. Oh my goodness, that would be a good background video actually. Taylor expansions. How quickly do you think we could cover Taylor expansion? No, no, okay, I shouldn't ask you.
Um, the scalar value Taylor expansions you can cover really fast if you do it the way I did it.
And then in my head, as you said that, I got a flashback to your paper.
Yeah.
Can be at a flash really fast, you say. Okay.
Because in all fairness, it was just 2 pages.
Density matters when you refer to pages. The length is density time page number.
Yeah, okay, fair.
You see, your just 2 pages translate to like 10 pages of video. And the derivatives one that's half an hour long is 13 pages.
Half an hour for scalar value Taylor expansions. God help us when we get to operator value Taylor expansions.
We want. Okay, the video is only 25 minutes. It's fine. I did also cut it short, but .mp4. My favorites. Oh, well, the perfect time I've picked. I'm gonna upload it to YouTube on stream. Hey, it's not like I'm using that internet anyway. Am I right? Or am I right? It's not like I'm streaming anything.
Yeah, definitely not. Who would have thunk?
Whomst would have thunketh. Okay, it's still exporting, so I can just leave it for now and get back to the matter at hand. So, this will be left implied. Genuinely, it might be one of my favorite jokes now, that, like leaving stuff implied.
Implications are nice, I guess.
And then what we get is the really neat trick. I genuinely do enjoy it a lot because, once again, the videos aren't as strict. We're trying to cover all the bases. We're not trying to do everything all at once. So if someone will want an accurate and like rigorous way to get into it, then they can read the paper. But in the video, I genuinely do like the switch of omega to Hamiltonians, because you basically have some kind of lambda multiplied by time has to be equal to, and then well, it has to be equal to 1.
Yeah,
Because we do
no
one.
units essentially.
So lambda has to be equal to frequency, and then the E equals h bar frequency. So frequency equals E by h bar. So this becomes Hamiltonian by h bar.
Yeah. I mean,
You're making me really worried because you do sound so extremely hesitant.
no, the thing is this part is actually something that I don't have any, what do we call it, objections on, because
Oh,
knowing that this operator, the omega, turns out to be the Hamiltonian is something that you can't do with maths. It's a purely physical phenomenon.
no, that's neat then.
Yeah, I mean, if you read the remark section, the very last paragraph addresses exactly this, that the fact that this operator turns out to be the Hamiltonian isn't actually something that you can derive from mathematical principles. You have to look at physical symmetries and whatnot.
I did not know that. That's actually really really neat. That is
Yeah,
that's physics capital P.
yeah,
Oh, that's actually phenomenal because genuinely up to this point everything could have just been considered like an abstract mathematical thought experiment. Nothing up to this point was actually tied to physics in any way. Like you,
yeah.
that is well, that's brilliant then because once we get there, what we get is the Hamiltonian term. The Hamiltonian term multiplied by the time evolution t naught alpha t. By the way, I've already mentioned it to you once, but I like that I use lambda when I'm referring to something. Just something.
Oh, yeah.
Yeah,
I think you've done it a few times.
yeah, where lambda just basically means I don't feel like writing it out, so have a lambda.
Yeah, I like lambdas. Lambdas are nice.
It genuinely, I know that I may be just paranoid and this may not be happening, but you, and not just right now, but in general, you do sound like a mathematician who's being held at gunpoint to pretend that he likes physics. That is genuine. Like 9 times out of 10, when I say out loud, like, "Oh, that could be a good explanation," that's what you sound like. Which, the thing is, I know that I could be paranoid and that could not be your thoughts on the matter. That's fair. But just in case they are, I really want to make that clear that if you have any objections to my explanations, then it is absolutely within your right to state them out loud. It's fine. It would be actually desired, in fact.
I mean, the thing is, we've all made a bit out of me like being a mathematician and all, but like I genuinely don't have that many problems with the way that, you phrase things because trust me, if we started doing it the mathematics way, no one would understand
I mean,
anything.
yeah,
I know
obviously,
that from
that's why I'm saying
experience.
that we're trying to cover all the bases, but not at the same time, right? Like the videos
Yeah.
will obviously be more understandable, less rigorous. The PDFs will be less understandable, more rigorous. That's the whole point of why we're dividing it. So
Yeah.
obviously, it doesn't have to be perfect. I'm just saying that just because it doesn't have to be perfect, doesn't mean we can't be aware of why it's imperfect. Like we don't want to. We don't like. Obviously, the videos aren't going to be rigorous, and there's going to be a lot of abuses of notation. There's going to be a lot of leaps of logic, etc., etc. And that's fine, but we still like. I still need to be aware of them. And if I'm stating something as equal when it's not, that's fine as long as I know that it's not, if you get what I mean. So, for example, in the very last bit of the derivatives video, I have the infinitesimal f, the thing I just joked about, infinitesimal g divided by infinitesimal x, right?
Oh yeah.
And so, like, me saying in the video that this is sort of just equals 0 times 0 divided by 0, and because you have two zeros right here, then they win over, so this gives you a 0. Like, this in the video is fine, because in context that makes sense. However, it is still important that this is absolutely not the fucking case. And so that's why
Yeah.
in that chapter, actually, I do this bit where whenever I say kind of, you get an asterisk, a massive asterisk
Yeah,
kind of
yeah,
on the
yeah,
screen.
yeah, yeah.
And so I say, okay, so our infinitesimal df is kind of like a 0, so you kind of get 0 times 0, which kind of beats out the bottom 0. So like it's absolutely fine to be nitpicky because it may not like change the video, but it is still really important that I'm aware of, how things are inaccurate. But yeah, this entire thing I just had to say like just in case you were trying to, uh, you know, just in case you were trying to be polite. This is not
No, 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 it's fine.
okay. Good in that case. In that case, I do
Yeah.
trust you. Don't worry. Anyhow, where was I? Oh yeah, I was in this Hamiltonian, and then from this Hamiltonian, we don't really have much more to do because what we do then is, what we do then is, we have the lambda equation. Where's my lambda equation? There is my beautiful, beautiful lambda equation. There we are. Now, I'm trying to come up with more words that can be crunified. Hi, the Greg. Hi. We take
OMG, Greg.
we take this equation.
More words that can be cranified. Let me have a think.
No, don't.
Have you done it with cactus yet?
Oh, I'm an idiot. I can't lumpify this.
Train it.
That doesn't even. That's not even close. That's you replacing MAK with crane. It shares one letter in common.
I mean, close enough.
It has one letter in common and 6 letters not. This has to be. I'm such an idiot. This has to be 1 minus I h bar, the whole shtick, h hat dt. And the reason why it has to be that, because what we're then doing is we're distributing it inside. I've reached the point of dealing with mathematics to the point where, like, the first thought that just came to my mind was, can you actually distribute it? But you know what? I have it noted down here, so I'm gonna trust the notebook. And in that case, what we get is we get this one minus, so we get the time evolution operator minus this times the time evolution operator. Right, the only pickle being this minus that. Okay, so we get, oh, why is this gonna be such a mess? Let's just do u, no, I need to know down the whole thing, damn it, t naught minus lambda, just this is our lambda, lambdified, u t naught. This is what we get, and all of it was equal to just on the very beginning u t plus dt on the state, once again state left implied, t naught. And so what this means is that then we bring this over to the other side and we get the difference between them is equal to this, and then what we do is we take the infinitesimal that's hiding in this lambda, we bring it to the other side, we divide both sides by the infinitesimal, and then what we get is we get effectively the derivative of the time evolution operator is equal to minus I h bar, minus I divided by h bar, Hamiltonian on the time evolution operator. There we go! Done did it. Jeez, that was... Crane pottery, that's not even one scale, that's not even close! For crying out loud. Okay, I'm pleased with this. The time evolution operator video can be quite nice.
Nice.
No, I just paid for the website. My phone just busted, you know. Okay, so this will be, I think, in 2 sections, which is maths and then analogy. Well, maths physics actually, because it will be a bit more physics-wise. And then the second portion will be the analogy, which will be just us interpreting everything we gotten in the math section. Alright, good. And then this one will be divided by recap. Then the next one will be hi Dereks Gaming, hi. We time-dependent state. And the state of the matter is that we need that, so then we do evolve in that state. Then we have properties of that state, properties of the time evolution operator, obviously, there we go. And then then we do a little bit of a leap, because then we have an equation of, according to YouTube, I'm the only viewer right now. Yeah, but YouTube doesn't actually keep track of stream statistics all that accurately. I have had times in the past where I had no one watching but people chatting, so t plus dt of the state, which is up to the derivative. This one will be hard to justify, so I feel like I'm just gonna go through with it. Big reveal, it's a derivative. Then this, we're going over the same thing with an analogy, which means we do time state first, then time dependent state, then evolving that state. The reason why because I don't remember, but I had this analogy for the linear algebra of quantum mechanics. Ash.
I'm listening.
Yeah, so basically, like when you have a particle, then a state of that particle is like an image that you're taking of that particle. Then an operator onto that state is just kind of like a filter that filters the image somehow, that you just hover over the image, and that's how you apply the filter. And then finally, the basis would be kind of like just doing something with that image. For example, a specific position basis would be kind of like cutting out a single pixel, or squishing it till only you have a single pixel. So that's the analogy. And the reason why I like it is because it can show off some certain interesting things. So for example, when you have the time evolution operator from itself, from t0 to t0, right?
Mm-hmm.
Then this doesn't change as the state. So what you can imagine it as is, you can just imagine it as a perfectly clear filter, or the identity.
Okay. Yeah.
And the reason why it's neat is because when you add dt in there, then it's almost perfectly clear, but the very subtle slight difference, infinitesimal difference of a filter. And that difference of a filter just shows you the change over time.
I mean, yeah, essentially what you're saying is correct, but just to be like super pedantic, um, it's not as much as you applying a filter on it, because applying a filter somehow implies that you're losing information, which, okay, kind of, but not really. What I would imagine is like
I mean,
you have a state and you're just, okay, you know what? The filter one is actually fine. There's no reason
yeah,
for
because
me
I
to.
mean, you're transforming the information. So, you know, the way I imagine it is that you have some kind of image of a particle, then I'm gonna
Yeah.
hover over it in Blender, a filter, and then once I hover that filter over the particle, what you get is just an image of the particle evolved. So there's gonna be a
Yeah.
particle on its own, and as I let the animation play, it's gonna change, and the image is going to, yeah. What are you doing? The Discord
it's-
call is showing at the bottom. Yeah, because we are in Discord. This is a Discord whiteboard.
Yeah, so essentially, yeah, when you're applying an operator on it, you're just like, you have all of the information encoded in a state, and then applying an operator is just extracting some particular information. So yeah, it works. Filter's fine. Filter's perfect, actually.
Why don't I have a way to message you? Where are you, Ash? Oh, that's where you are. Why are you
I'm right
so low? Why are you so low in my DMs? I do not I do not have you as a friend, that makes sense. I very reluctantly have Remco as a friend because he blackmailed me emotionally.
Emotionally blackmailed is a
You were
crazy
there!
statement. I knew what went down there. I was right there when it all happened, make it.
don't tell me about what's written on the stone, which I was there when it was written. Hi there, Inadequate Duck, how you doing? Make it's been so
my
long since I've seen you. Well, how things been, Duck?
Duck was ducking around.
Not many people actually can say it's been so long since I've seen you. Lucky you are. All right, that's enough of the goofiness. How is the Brazen Kids video looking? Also, wait, because then it's going to be evolving that state, right? Then it's going to be motivation for the big derivation, and then interpretation of the derivative, and then final segment. It's all coming together, which is what the time evolution operator actually is. Oh, just solving the time evolution operator. It's been an entire year. It has been a year, hasn't it? Jeez. I genuinely haven't celebrated New Year's much, so all of the jokes like that don't land for me. Are we doing math make it? Physics, funny enough, believe it or not. This is, well, I mean, this is quite a whiteboard by now. But mainly, the bottom right corner is mathematics, the top left is physics, and it's sort of like a spectrum. Right now we're more on the physics side. Actually, is there anything else we need to list here? No, that should be it. So. Oh yeah, this is finished. I can record this and I can actually start working on this video. Oh, that would be quite productive of me. That would be good. Physics is just math with drugs. I would say physics is what happens when mathematicians don't have enough drugs, and then they actually have to acknowledge reality. No, I said smoke weed and general theory of relativity. I know, I made a whole video about it. Okay. Brilliant, beautiful, splendid. Oh, I just realized how much more work I have left in store. Did I have a Taylor expansions video actually planned? No. Well, new document then. Taylor. But that's a maybe. We shall see. The shorter version is obvious, probably, This is going to be the revision. Okay. Right. Brazen Kits.
Physics is a subset of math. Honestly, disagree.
Yeah, there's a difference. That's because in physics you have like, it's not exactly extra rules. It's more like there's a difference in motivation.
There are things entirely that you just can't make sense or you can't derive with math that are in physics.
Yeah, and on the other hand, there are certain things that in physics would be impossible, but in mathematics you just do them because why not? Basically, think about it this way. The goal of physics is to model reality as accurately as possible. Mathematics doesn't have a goal. You just do whatever you want. It's just...
I like it.
I'm gonna give you approval on that. When I spoke to most mathematicians I speak to, that is like basically the idea they usually hold, which is that in mathematics you don't ever have an actual restriction. You know that the whole deal of like we're not inventing mathematics, we're discovering it. That's where it stems from. It stems from that idea that since you have no restrictions whatsoever, then it's more like a more fundamental thing. So physics is math with a goal and extra rules and some limitations. Not really. No, not really. Well, we just had a conversation over this, and apparently the Hamiltonian in the Taylor expansion, right? Another thing is that, you know what? I'm getting sidetracked. So physics is for cowards. I would say it's a trade-off. You know, you lose a certain degree of creativity, but in return you get a little bit more of a challenge, I would say. So it's not really that. Okay, my choice of words here is very careful, so do mind it. I'm not saying that math is easier. I'm saying that math would be an easier thing to pursue. That's because in mathematics, when you're pursuing something, when you're going into some kind of topic in depth, then basically the more you get into it, the more interesting things you find. Some of them could take the form of proofs, some of them could take the form of disproving things, but all of them are interesting. In physics, however, you care more about how accurate things get. So when you have something that's inaccurate, it can be interesting, but it's not really all that great physics-wise. Do you know the name of the smallest number? What do you mean by smallest number? You mean like 0, or you mean minus infinity? What do you mean? Do you know the derivative of Hamiltonian with respect to time is 0? Are you talking about a time-dependent one? I mean, because
Yeah, exactly.
if you're not talking about a time-dependent one, then yeah, I would imagine it's 0. I can name you a whole bunch of functions whose derivative in relation to time is 0, if you'd like.
Smallest positive non-zero number. Epsilon, infinitesimal.
I imagine it will be some infinitesimal. I mean, but I don't. What I find funny is that X Gaming said the smallest number, not a smallest number. So suggesting that, because like that would suggest that there is some kind of named number that's smaller than infinitesimal. That's what it suggests.
No. I mean, infinitesimal is the smallest number. Like,
But it's not really the smallest number. It's a smallest number. That I know that it may seem like a very semantic, pedantic sort of thing to be upset about, but you know, there are certain constants that have their
oh no, no,
names.
no, no. I mean, yes. I completely understand where you're coming from. But there is this small sub-branch of mathematics called non-standard analysis, and in that branch, they actually formalize epsilon. Like, they actually define it that it's the smallest real number greater than zero. So it
Oh,
actually
but
becomes the.
that's so cheesy though. No, I don't like that. Like do you asking someone, do you know what's the smallest number, and then picking the number that's defined as the smallest number is that's so dumb.
The, the problem is, like, you can't do it otherwise because the Archimedean property will always guarantee a smaller number unless you define it that, like, no,
That is
this is the limit.
so dumb. Can you imagine
10 to
like
the power minus infinity, bruh.
can you
Operations with infinity is not defined. You need to put a limit on the backside.
That's kind of the, hey, do you know what's the fastest particle? Yes, the hypertachyon. Oh, I defined it as a hypothetical particle that would be the fastest, that would travel at the limit. That's so dumb.
No, but the thing is, it works.
I mean,
Right?
obviously it
Like,
works. It would work with anything. Hey, do you know what's the
not
largest number?
the largest number.
I call it
Two.
the Maketillion, and I've defined it as the largest number. Oh,
Uh, Definitions are always amazing.
That actually genuinely made me laugh so much.
The
That's,
sheer amount of bullshit you can do with them sometimes.
I mean, yeah, but the idea of asking, of giving someone a fun fact of, do you know what's X, and then just giving X that's just itself by definition, is so funny. Why are there so many
Why are
letters
there
in
so many letters?
physics? What do you mean? Well, I mean, there
My
are.
guy, you have not seen mathematicians use letters. I'm telling you,
Okay.
it's worse.
I mean, relativity could take the cake.
No, relativity, the problem with relativity is that,
Tensors,
yeah, they have a lot of mu nu
yeah.
and
I
rho. So
think
actually, th- that's actually cutting it pretty close. But in my notes, in the notes I have on like micro local analysis, we use fucking, I think if I recall correctly, capital theta.
really running out. 357
357.
blank. Next number. Well, I can sort it out for you. I'm
I would
guessing.
say 11.
Oh, I would say the most logical, which I would say that it has to be a polynomial that is defined as these 3 points. All of them are spaced out as even increments. So all we need to do is we just need to basically solve for a polynomial of ax cubed plus bx squared plus cx plus d. Wait, would it be fourth order or third order or fifth order? Which one would it be? If we're looking for four, no, three, because three defines it, yeah. Which means that this one wouldn't actually exist, and then only three define it. Yeah, and then we just need to find a polynomial where if we put where f of x is equal to this. There we go. And then f of x naught is equal to 3. F of x naught plus delta x is equal to 5. Then f of x naught plus 2 delta x is equal to 7. And then we just need to solve it for f of x naught plus 3 delta x. And then we're gonna get our answer. Unless, of course, it's not the answer, which is completely plausible.
I don't know. I just said 11.
It's the second order, since endpoints can do an n minus 1 degree polynomial. Alright, yeah, so it would be 3. I always just remember it as the amount of constants, that's why I think of it.
It's 9? No, it isn't. It's 11.
Well, I mean, the pickle is that X Gaming, came up with the series, so it could be literally
No,
anything.
he's still wrong. 11. I mean, clearly.
It could be any number in existence, and possibly some in non-existence.
You see, this is why complex analysis is so nice. Like, if you have a function, right, and you know its values on some open subset, like any open subset, then if you can extend that function to the entire complex plane, that extension is unique.
Oh damn!
But that only works in
For
complex analysis. In real functions, if you want to extend a function, then there are like infinitely many ways you can extend it.
Hold on, we'll get back to that in a second because that's actually quite mind-boggling. But I just want to say it's a trick question because I can say 9 or 11. X Gaming, you can also say 10, 1, 7, pi, 2.5, minus 13, 3 plus I7. You can say whatever you want in that series. You're not restricted to just 9 or 11. You can say whatever you want. It would work just fine. But back to it, why does it only works on a complex plane?
Um, It probably has to do something with the fact that the complex numbers are algebraically closed, which means that every polynomial in the complex numbers has a solution in the complex numbers. But how exactly this property is derived or how the theorem is proved is something I haven't looked into yet. It's called analytic continuation, and it's a pretty fucking important thing in complex analysis. Like it's right up there with holomorphism.
But it's counting and just random numbers. Yeah, but that's the point of a series that's completely undefined. It's undefined. You can say whatever. It's not a set of random numbers. X gaming series, if you don't define anything about them, then they're completely undefined. That's kind of I honestly don't feel like I need to justify my point much here. I feel like even if someone was I feel like even if someone was like trying to be extremely completely rigorous here, the take of if something is undefined then it's not defined, that would still like
The floor here is made out of floor.
the thing is when you have a series, unless there are some properties of a series that I'm not aware of. Series mathematics.
No, series can be random. Like if he said that it was an arithmetic progression, then we would be locked into nine
Yeah, but
essentially.
there was nothing specified. So basically, for example, X
Yeah.
gaming, where I could hold on, let me just allow me to give you an example, X gaming, so that you can see what I mean. But first I need to do one thing, like quickly. There we go.
Do I not have fire? Oh my God, what am I doing in life?
Humans 700 million years ago. There weren't any humans 700 million years ago, but I'm doing another thing with mathematics and I genuinely couldn't be bothered to for a second think about how many years in the past I wanted to go.
Have a tier 8 boiler or greater. Oh my God.
What are you doing right now?
I'm playing game.
What game are you playing?
It's called The Perfect Tower 2.
You made my trick question sound dumb. No offense to you, X Gaming, but it very much was not a trick question.
Was pretty dumb.
The thing is, how would I phrase it to be how I want? Well, the pickle is, X Gaming, that there is what you're trying to do, right? What you're trying to do is make people think that this series right here is defined by being and then blank. What you want people to do is you want them to think that this series, I'm gonna do it with function notation because I once again couldn't be bothered to actually remember what it is, notation for series, that it is defined either as 2n minus 1, so odd number. Well, I guess this would be plus 2, so plus 1, right? No, plus. Depends if you're indexing at 1. Doesn't matter, I'm thinking way too much before this is completely irrelevant. Or if they are thinking that it is actually odd numbers, then you want it to be primes, which I'm pretty certain just pi function of n. And that's what you want, right? But the problem here is that this only works if someone is certain of an answer. Because if someone is certain of an answer, then they won't stop and think. If someone is certain that this is odd numbers, then yeah, they will just say a 9 right away. If someone is certain that it's primes, then they will say 11. However, if they just stop and think for half a second and they realize that you've told them basically nothing about this, and then they realize that it can be any goddamn series in existence. The thing is, there is no way for you to phrase it for it to be a tricky question, because it's a maths problem. And at that, it is a really simple maths problem. And I mean like trivially simple. Trick questions won't really work in mathematics all that well because you either have something that's a really simple trick question, which will be easily like demolished by just thinking for half a second, or you can have a really complicated tricky question, but then that's a problem because then that will only appeal to people who, those more complicated questions will only appeal to people who are into mathematics, and then they will just spend enough time thinking about it until it's no longer tricky. Like a really good tricky maths question was the one that Friedel and Brown did a while back ago. I remember I have this video that I haven't seen because I don't watch science creators because I'm worried I'm gonna plagiarize their work, but I have seen segments of it because someone showed them to me, of tricking people with a triangle, where Friedel and Brown basically showcased a triangle in a way that made it seem impossible. Like it was something like one of the sides was unreasonably longer than the other sides. If I'm not mistaken, it was the fact that when you have a triangle, then if you have sides A, B, and C, then A has to be smaller than C plus B. Because in order for it to be equal to C plus B, then the triangle would have to be completely flat. If I'm not mistaken, it was this equality, but I could be wrong. I don't remember. It was a long time ago. The point is, the way that Friedel and Brown achieved this was by drawing the rectangle in an extremely misleading way, whilst at the same time not actually defining the things that made it incorrect, and only leaving it as drawing as misleading. Something with drawing like a right angle when in reality would never be a right angle, etc. So then everyone watching just assumed that there was a right angle when in reality they shouldn't have. And there we go, tricky question. But that is a genuinely really difficult thing to do with maths. Once again, I'm paraphrasing it because it was a really long time ago and I just straight up don't remember that video. Can an equilateral triangle fit on an integer grid? Which one is
I think
equilateral? That's the one that has all sides the same.
the answer to this was no. I think at least not on.
I think it's provable.
Not on a square grid. Like there was a video on this. Some YouTuber made a video on this, and I saw.
I think it's easily provable, is not? Or at least it's definitely easily provable if it's lying flat. If it's rotated, then it becomes a bit tricky. But we can at least do it for lying flat, because then A would have to be an integer. That's the dumbest thing, where N is just belongs to Z. And then this would be H. H would be equal to A squared is equal to A squared by 4 plus H squared. So this flips to the other side, it becomes A squared by 4 is equal to...
I'll be right back.
Root is equal to H. So this is our height, but then this is our N, which means the coordinate of this point then would be X and Y, and the X coordinate would be equal to... If we just assume this to be 0 point just for the sake of simplicity, that would limit us only to even A's though. Would it not? No, it would limit us to only odd. To... Then says 2D, 3D rotated. I don't know if 3D rotations would matter much. They might, but this actually might be interesting because it really feels like there could be a way to generalize it. So if you prove that with rotations in 2 dimensions, it wouldn't work for any amount of dimensions. It's any, but rotations get tricky actually, the more dimensions you add. So maybe there won't be. I don't have the math skills for that though. Not nearly. Rotations in 2 dimensions kill me. And I deal with goddamn graphics. video. Now, next we have the states, which contain information about our particle. In the last video, I visualized them as just images. Simple. That is actually all the we need. So, our video width. This entire thing I could do in Manem actually, because it would just be mathematics.
Back.
Welcome back. Patience, depth. And the analogy as well. So if you get lost in maths, don't worry, it will get sent up. Lovely. Lovely, lovely, lovely. With every passing day in my progress track, I am just getting more and more behind, and I have exhausted most of the time, so this is not great. It's pretty bad, in fact. It's really bad. Yeah, yes, it can, because you can make it perpendicular to the grid, which will make the projection just a line. Or if you project it like that, but then do you still consider the rectangle, triangle? Because then you are talking about the projection, which it is different, because if we consider our projection to be like an f of our triangle x, then there is a difference between talking about an x or talking about f of x. Those do not have to share properties. It's 3D, so in a 3D viewpoint it is. Yeah, no, because the projection, like this right here is your three-dimensional triangle in R3. But this right here is that triangle mapped onto R2. So when you're thinking of it as a line, then it's no longer that triangle, it is in R2. What's more, this is actually quite a simple map now I think about it, because if we imagine our triangle as just 3 points, each one of them being a vector, x, y, z, then the map f of x, or f of v, I guess, doesn't matter, the map would just be a simple map from R3 to R2, where we just remove the z. That's about as simple of a map as you can get. So in that case, your triangle after being mapped would be, if the side length was something like a 2, for example, it would be 1, 0, 0, 0, 0, minus 1, 0, if I'm not mistaken.
Not to be that guy, but that is very coping of you.
Of me?
No, not you, of X Gaming. To suddenly lift it up into another dimension and then project it back down so it's forced into a straight line. That's... Oh my god.
The problem here is that your projection is making it no longer a triangle. What's more, most of the time it would no longer be an even equilateral triangle with this definition.
I wonder if I can think of a nice puzzle for you guys, but the problem is I can't. Either what I say is going to be extremely easy or disproportionately difficult. There is no in
I don't
between.
mean to be that guy, Ash. But when you say, I'm thinking if I can think of a good puzzle for you, but there is a problem, then I kind of assume that the problem is that you can't. That's kind of like,
Yeah. Let me see. Let me see. There has to be something that I can ask.
states. This state describes how we have gotten these with of days, but what's that? Oh, what's that? Well, that would be the time independence. So right now, this state changes with time, which means that I actually starting with maths and only then doing the analogies, sort of idiotic.
Okay. I have a good one.
Alright, go ahead.
Check this one out. Um.
That sounds interesting. Alright, hold on.
There you go.
Area of a circle is equal to pi r squared. Perimeter is equal to pi r. Area of a square r squared or perimeter of a square 4r. Note how the area and perimeter of a circle are related by derivative. Why is it different for a square? Oh, I know the answer to this. As in, I have
Well,
included it in the videos like 2 or 3 times.
yay. I'm at 125 XP. Or 150 now. You didn't pass geometry, but you were just talking about fucking projections and shit. What is this double standard?
I didn't pass the class, but I did teach some of it to myself.
Why is not two? a crazy answer.
I mean, hey, inadequate isn't inadequate duck isn't not wrong.
I mean, yeah, it's not wrong, but I meant why are they not related by a derivative, like a circle and a, like in the case of a circle, not why they're algebraically not equal. Crazy.
I like to imagine that inadequate duck just wrote down two not equal pi, and then like dropped the pen like a micron. Then there was an explosion behind him, and then you Ash just got obliterated.
I got like atomized, subatomized even.
Shall I? I can. By the way, if anyone's curious, I can give the answer because I have a pretty neat geometric. I don't want to call it a proof, but I have a pretty neat geometric visualization for why that's the case.
Yeah, go ahead.
It's again sounds so disappointed. Well, the thing is, X Gaming, I hope you will learn from today about overestimating your abilities, and you will learn that you should probably not treat yourself as if you know a lot about the topic when you do not, because trying to ask tricky questions about geometry is not a good idea if you don't know much about geometry. But basically, when you have a square, so I need some space on the board. Jeez, there we go. This corner looks nice. Let's consider a square and let's consider a circle. Right. When we're thinking about their areas, well, we obviously know that when we have a side r of a square, then the area is r squared. That's kind of where the names come from. But the question is why? Well, the answer why is because we have this length right here. We have this length right here. We multiply them together, we're getting the area. Congratulations. However, another thing we can do is we can take our r, right? And instead of defining it as the whole length, we can define it as half the length. This is our new r. In that case, what would be the area of our square? Well, that would be r squared gives us this tiny little square in the corner, which only fills 1/4 of the big square. So we need to multiply by 4. Congrats! We have gotten our area for a square. Now, what will be the area for a circle? Well, the r didn't change. It is still the same. It is still our new r. But what would be the area in that case? We can take the same approach. We can square it, in which case it would give us somewhat of a quarter. But the issue is that it gives us an overshoot of a quarter. So we need kind of correction factor. We need to take this area and we need to multiply it down by only this thing on the inside. If only we had some kind of constant that could do that. Oh, there is. It's pi by 4. So it would be pi by 4 times 4. Wait, am I thinking? Yeah, pi by 4 times 4 r squared. Them's the area. Now, that is the area. Perimeter, however, is different, because when it comes to the perimeter, we cannot take the same approach. As in, oh jeez. Inadequate Doug, X Gaming, are you both familiar with limits? Not as a concept, more as applied limits. As in, have you both? Yes, but I'm not asking as a concept of limit. I'm asking how much time have you spent like working with limits. My math knowledge is all over the place, not by another about them. Like Riemann sums, okay. Both of those answers are tricky in that case. Huh. Alright, in that case, I would like to take an additional 5 minutes to rethink my answer.
Well, I can provide an integration-based proof.
Yeah, can you do it without a limit though?
Yeah.
You can.
Yeah, I mean,
Go ahead and
where are you drawing though? I can't see your name
bottom
tag.
left corner.
Bottom left. Okay, which one's my left? Okay, there it is. Found you. Ah. Okay. So one way you can think about it is instead of thinking about the area first, think about the perimeter first. So if I have my Cartesian plane, wow, that's not straight at all. If I have my Cartesian plane like this, then if I want to define a circle here, I have an upper semicircular arc here, a lower semicircular arc here, right? And now the idea is, where's my pen again? The idea is that this here has a length of pi times r, the upper arc. The lower arc has a length of pi times r, right?
Mm-hmm.
And so you add them up, you get 2 pi r. And then what you do is you integrate both of these regions separately. So you're going to integrate the upper region and you're going to get the shaded area here. That's gonna be equal to pi r squared over 2. And then you're gonna do the same thing for the lower region here. And you'll end up with pi r squared over 2 again. And then you add them both up and you essentially get the area of a circle. Now the reason why for a square, wait, wrong color. The reason why for a square it's slightly different, it's not big enough, is because when you consider a square, you only need 2 lines to have integral bounds, right? So because you only need the upper region from here and the lower region from here. And these, both of these are bound by something of r and something of r. These things here, they don't actually contribute to the integral. So that's why you don't end up with something like 4r when you take the derivative, because these are like imaginary boundaries. If we have like a real square, obviously we count them when we're considering the perimeter of a proper square. But when it comes to derivatives, the derivatives only care about the curves that are bounding the region. And when it comes to bounding the region, the side curves don't actually play any role. It's only just the top and the bottom one. That's why we only get 2r instead of 4r. Yeah, essentially. Oh, inadequate duck, you know it. Very nice.
Yeah, makes sense. That does make sense. No, gonna lie, I was just going at it completely backwards.
I mean, yeah, there are many ways. There are many ways to think about it. This is
I was
just
gonna
the
do it with
way.
a derivative, and only once I got into, like, I was gonna do it as a derivative of area. But only once I've got into that area did I realize that it's not actually quite as trivial.
Yeah, integral of the perimeter is,
It is much.
I feel, a bit straightforward.
It
Yeah.
it is just much more straightforward. It's better. Yeah.
Yeah. Oh, game engine. Make Flappy Bird instead game engine.
I'm skeptical of the making a game engine, because if your knowledge of computer science, you clearly have the confidence. I'm not denying you that. However, if your knowledge of computer science matches your knowledge of mathematics, considering how you seem to be similarly confident in both fields, that does make me a fair bit skeptical of your game engine.
I mean, as long as the game engine is Turing complete, it should be fine.
My nose is getting all over the place. Wouldn't you prefer to start with something simpler than a game engine? Like some kind of physics calculator, for example? You did. What did you make before the game engine? Time for the states. Maybe I could do both at the same time. Maybe instead of dividing it into two big sections, I could do maths and then visualizing. That sounds better. I made 3 of them already, and Minecraft copies and simple encrypting stuff. You've made 3, and what have you made those engines?
Where's my phone?
Because earlier on you were a little bit like, I don't want to say confused because I'm not quite confused. In what did you make those engines? Because earlier on, I don't want to say you were confused because you were, but you were a bit confounded, let's say, when it comes to 3D to 2D projections. And that's kind of a requirement, a pretty big requirement when it comes to game engines, especially. Well, graphics engines, but game engines are just bigger graphics engines. Yeah, until this. I haven't needed to think about it for a long time. I've got some of it. What time is it actually? Oh, it's 4:30. Damn it. I'm hungry and I just can't even go out and buy something to eat. Because it's the middle of the night and apparently shops are closed. I used to live right next to this absolutely phenomenal burger place that had cheap burgers, they tasted good, and it was open up to 3 in the morning. My goodness. That was life. Damn indeed. Time. Take the picture at T. What? We can take the picture at T1. Different pictures, but that's because they are states. The same part at different times. burgers taste good. Those ones were really good. Those ones were really bloody delicious. Okay, well, in that case, I think that'll be it for this stream. I think I'm gonna just go outside and scavenge for food, see what I can find.
Fair enough.
And then I'll do another stream in a couple of hours. And
Alright,
hopefully
good
by then I'll
luck.
have some more progress on the videos. Yep. And for now, that'll be it. Thank you very much for watching and have a great day. Bye.